In this lesson, we're going to look at the periodic trends of ionization energy, electron affinity, and the relative reactivity of metals and nonmetals. So if you recall, we had talked originally about how the periodic table is set up in increasing atomic number. So the number of protons we have as we move from left to right increases, and then as we move down to the next period, we also, the next period. So as we're moving down a group, we also have an increase in the atomic number. So that is how many protons an atom has. And what we also noticed is as we move down a group, because we keep adding another level of electron orbitals or another energy level, that is going to increase the size of the atom. However, as we move across a period, what we found was that even though the number of protons and electrons increased, because we were on the same electron shell or energy orbital, that we weren't increasing how many energy levels there were, and the increase in protons meant that there was a greater attraction pulling the electrons in. And so it pulled those electrons in that valence shell closer. So as we moved across a period, we actually saw the atomic size decrease. And that's going to be important for us for the first two trends we look at, because there is a relationship to the atomic size and those, and actually to the reactivity as well. So this is, again, the summary of the different trends. So atomic radius, as we just said, increases as we move down, as we increase energy shells. But as we move across a period, there's a decrease in the radius because the increase in protons increases the attraction and pulls those electrons in closer. And that is going to be the opposite to what we see for electron affinity and also ionization energy. Those are the opposite trends to the atomic radius. So ionization energy, what is that? This is the amount of energy that we need to take an electron away from that valence shell. So just removing one electron from the valence shell. So the trend that we see is that as the size of the atom decreases, as we move across a period, there's an increase in the energy needed to remove an electron. And as we move down a group, as we increase the size of the atom, there's a decrease in the energy needed to remove an electron. So here is a visual of that. We see an increase as we are moving across and a decrease as we move down, or our increases as we move up. So why is that happening? So there's a direct relation, as I said earlier, to the size of the atom or the atomic radius. The smaller the radius of the atom is, the closer the electrons are to the nucleus, which is what is holding those electrons in place. So as we have more protons across a period, there's a stronger attraction pulling those electrons closer, which makes it harder to remove an electron. So those electrons are being held closer, they're held more tightly, there's a bigger force holding those in, and that means we need a lot more energy to pull an electron away. So electrons that are closer are a lot more strongly attracted, and then we're going to need a lot more energy. So that I've already said. And then the reverse is also true. The larger the radius is, the further the electrons are to that electrostatic charge from the nucleus. And then there is a smaller force of attraction, which makes it a lot easier to take an electron away. So there's less energy needed to remove an electron in that outer shell. Electron affinity, this is the energy that is released when we add an electron. So specifically, the atom needs to be in a neutral, so same number of protons and electrons, and then gaseous form for this to happen. And then because we are adding an electron, it is becoming a negatively charged ion. So what trend do we see in terms of how much energy is released when we add an electron? When we move across the period, there is an increase in the amount of energy released, and there is a decrease as we move down the group. So why is that? So here's just a visual to show the amount of energy. So why does that happen? Once again, it's related to the atomic radius. So the smaller the radius is, the easier it is to add an electron, because once again, we are closer to the attraction, the force of attraction from the protons in the nucleus. So the closer we are to there, the easier it is for the protons in the nucleus to pull an electron in. So the better they are at pulling an electron in, the less energy that is needed. So when atoms are smaller, we have a greater attraction for the electrons, so same as before, and because of that, more energy is going to get released when an electron is gained. And then the reverse is true. So as an atom is larger, there's going to be less attraction to that outside, and so it's not going to need, there's not going to be a lot of energy that is released when an electron gets gained. Okay, last couple, so reactivity of metals, and then we'll look at nonmetals. So the trend for metals is there's a decrease in reactivity across the period and an increase as we move down a group. So as we take a look at our metals here, and I've removed hydrogen because that's not a metal. So as we move down a group here, and we're talking about our metals, the metals are going to increase in size. And when we think about this part of the periodic table, these are going to lose electrons. So when we talk about reactivity, we're talking about forming bonds with something else. So for example, sodium can form a bond with chlorine. And sodium in its valence shell has 1 electron. So in order for this to happen, that electron is going to be lost. And that's the idea that is going to help us explain the trend of, as we move down, there's an increase in reactivity. So as that 1 electron is getting lost, 2 in the case of group 2 atoms, it is easier to pull away an electron in an outer shell when it's in the 7th shell than for one that is in the 3rd shell. So there's our trends. So once again, related to the size. So as metals, as you move down a group, the metals become more reactive because the size of the atom increases, and that means that the furthest electron, which we are going to lose in the case of metals reacting, that furthest electron is further away from the nucleus, and so there's less of an attraction. So it's a lot easier to lose that valence electron when it is further away, and that makes it more reactive. So if we move across the period, the metals are going to become less reactive because the size of the atom decreases as we move across a period. And as the metal gets smaller, those valence electrons are going to be closer to the nucleus. So there's going to be a greater attraction between that valence electron and the nucleus, which makes it a lot more difficult for that valence electron to be lost. So as we move across a period, the metals are going to get less reactive. For nonmetals, the trend that we have is they increase as we move across the period and decrease in reactivity as we move down the group. So as we look at nonmetals, so we'll use fluorine as an example here. For fluorine, it has 7 valence electrons. And for fluorine to react to form a compound with something else, it needs to gain 1 electron. And so as we move down a group, the size of our atom gets larger. The larger it is, the further away from the nucleus, which is what is going to attract electrons to pull them in. And so as we move up and we have less energy levels, the force of the nucleus to pull in this outer electron is going to be a lot greater because we have few levels, energy levels. So here we're in the second level. And so as we move down a group, the nonmetals are going to get less reactive. And then as we move across, because there is a decrease in the size, so remember our increased protons here pull that valence shell tighter in. So same idea that the smaller it gets, the easier it is to pull in electrons, which makes it more attractive. So all of that is on here in text, so it's related to the size of the atom. They become less reactive as we move down a group because the size increases. So this is the reverse of metals, and it's because we have a reverse in terms of a gain or loss of electrons. So for metals, we are wanting to pull in an electron. So the closer we are to the nucleus, the easier it is to pull in an electron. So as we move down a group, the size gets larger, that the valence electron is further away, which means it's a lot harder to pull it in. There's less force from the nucleus pulling on that electron. So it's harder to gain electrons, which means the reactivity decreases. And then as we move across the period, the size decreases because we have more protons pulling in those valence electrons more tightly. And so it's a lot easier then to pull in an electron, which makes it more reactive. So it's easier to gain electrons, and then that increases the reactivity as we move across the period.